afternoon, everybody. Well, I just want to let you know that this afternoon we will be going over Chapter 7, which is balancing equations. And what I would like to do is to jumpstart our afternoon with a song. So here's a little bit of background knowledge about myself. Okay, so this song is called Chemical Reaction Types, and it is going to be sung to the Bee Gees tune Staying Alive. So are all of you familiar with that song?
Yes.
Well, this song came out in 1978, the year I was born, so I'm really dating myself here. And I've also been nicknamed the Dancing Queen because my parents were disco dancers. So when I created the song, I was thinking of my parents and of all of you. So here it goes. Well, you can tell a chemical reaction type by seeing what you've got in a synthesis reaction. Two elements form a compound in a decomposition reaction. A compound breaks down into its components in a single displacement reaction. An element replaces one compound in a double displacement reaction. Two compounds form two new ones. During combustion, a hydrocarbon reacts with oxygen to produce carbon dioxide, water, and water.
All right.
So what we're going to do today is we're going to apply the chemical concepts of chemical reaction types to this worksheet here. But before doing so, we need to balance the equation. So I've given you a visual aid, and it says balancing equation guidelines and the word minnow. So I made up that word. So the first kind of substances that we can balance, what does M stand for? Metals. And what about the I?
Ions.
Ions. So like the polyatomic ions have to be the same on both sides of the equation so that you can balance them as one single unit. What does the N stand for?
Non-metals.
Non-metals. And what about O?
Oxygen.
And then what are we going to try balancing last?
Hydrogen.
Okay, so like I actually thought about the lab manager when I came up with this scheme, because what she has to do is take an inventory of the supplies and materials and the chemical substances that you're going to be using in lab so that there's enough for all of you to use. Okay, so what we're going to do is we're going to be doing her job this afternoon. So what I would like to do is to illustrate an example. So if you could please turn to the worksheet that says Study Exercise 5 with chemical equations. We're going to work on number 9 on the back side of the page. Okay, so again, this is Chapter 7, and this is balancing equations. So let's take up number 9. Okay, so it says HNO3 plus barium hydroxide yields barium nitrate plus water. Okay, so first things first, what do we call substances on the left side of the equation? Reactants. So what we're going to do is draw an inventory table. Okay, so put reactants here. And what do we call chemical substances on the right side of the equation? Products. Very good. Okay, so if we use the minnow word scheme, what are we going to try balancing first? The metals. Do you see any metals up there? Oh, I'm sorry. Yeah. And as you said, hydrogen is a non-metal, so we'll save that for later for balancing, but let's try on the left side of the equation? One. How many bariums do you have on the right side of the equation?
One.
Okay. Do you see any more metals up there? No? Okay, so what's the next? Well, what's the next thing we're going to balance since we don't see any other metals up there? Oh, ions. Do you see any polyatomic ions up here that look the same on both sides of the equation? Nitrate. Okay, so you could consider these to be a single unit. So how many nitrates do you see on the left side? One. How many do you see on the right side? Well, not 6, but 2. You're thinking of the number of oxygens. So yes, when you have like NO3 on both sides, you can consider them to be a single unit.
So can I do like oxygen, nitrogen, if I want to?
You can do it that way. Yeah, you could break them apart if you would like to, but I'm just showing you a shortcut. Okay, what's the next thing we need to balance here? Do you see any nonmetals that are not oxygen or hydrogen? Yeah, I don't see any others up there. So what should we try balancing first, the oxygen or the hydrogen, according to our Minnow word scheme? Oxygen. Okay, so we're not going to include the oxygen and the nitrate because we already took care of that. So let's look at the oxygen in OH here and in water. Okay, so I heard of 2. And then we have 1 on the other side. And what's the last thing we're going to balance here? Hydrogen. So, how many hydrogens do we have on the left side?
3.
3.
Oh,
Because of the 2.
yeah, well, you do definitely have 3. I just the first one there. And then how many do we have on the right side? 2. Okay, so now that you have your inventory, let's try balancing these. Well, our bariums are balanced, so we don't worry about those for now. Okay, what about our nitrates? How can we get 2 of them on the left side of the equation?
By adding 2.
Okay, by adding 2, where am I going to put the 2?
In front of the 8.
Okay, so now we have 2 nitrates. Wow, what's that do to our number of hydrogens?
So we have 5.
Oh, let's see, or actually we have 2 here and 2 here. So 4.
Then you're gonna add.
Already added 2. Where should I put that to? On the product side? So in front of water?
Yes.
Okay, so how many hydrogens do we have there? 4. But now our number of oxygens are changing. So how many oxygens do we have here? 2. So when your numbers look the same, because you have to have the same amount of elements on both sides of the equation, you know your equation is balanced. Well, let's take this a step further and figure out what the chemical reaction type is using our song. Okay, so looking at HNO3, is this an element or a compound?
Compound.
What about barium hydroxide? Is that an element or a compound?
Compound.
Okay, barium nitrate, is that an element or a compound?
Compound.
Compound. And what about water? Is that an element or a compound? Compound. Okay, so looking at our song, what chemical reaction type do you think this is?
Double displacement.
I heard double